Hi friends, in this video we will discuss about IPSec VPN. But before discussing about IPSec VPN, there are some questions in our mind that why we will use it. What is the requirement here of IPSec VPN? So for better understanding, we will go through a diagram. Please have patience here. Okay, assume we have two branches here, branch 1 and branch 2. Okay, branch 1 has a lane, for example 192.168.101.0/24, and here 192.168.102.0 at slash 24. Now what we want here, we want that branch 1 lane should be able to communicate with branch 2 lane, and branch 2 lane should be able to communicate with branch 1 lane. Yes, if we want this reachability, we required a leased line here. If we will purchase leased line from branch 1 to branch 2, if we will purchase a dedicated line, that is called here leased line. Okay, now it is costly. If we will talk about speed, speed will be slow. But here we will get one thing, yes, that is security. Yes, actually, if you will purchase a leased line, that is completely you have owned. No one has right to access it. So here we can say, if you are purchasing leased line, then first advantage or whatever the characteristics is here, costly. You have to pay a lot of money to the service provider here. Second, if you want to get the speed, definitely you will get a slow speed here. Next one, the best thing is here security. You have no information of other, same other has no information about you, so there is no security problem here. But here thing is this, when we purchase anything, then cost always matter. So here we also have an another link, that is means we will connect both branches to the ISP, and such kind of link is called broadband connections. Okay, if we will talk about broadband connection, it will very cheap in the cost. Second thing here, speed will be fast. And third problem is here, that here there is a problem, that security. ISP means it is a platform where we can reach to anyone, which is public. So same problem is here, anyone can easily reach to us. Okay, so now what we want, if we purchase this broadband connection, then we can also communicate with another branch using public network. But when we talk about public network, we consider public network as a untrusted network. So we don't want, when we communicate with another branch using public network, another user should be able to access or see our data. So for that, what we do, yes, we will implement here VPN. So that is the main reason here, when we connect our branch to each other, we have here such kind of connectivity. For example, we have here lease line, which are very costly. We also have broadband connection, which are very cheap. So if we will talk about the money, definitely sure we will give the preference to the broadband link. Okay, now what happened to improve the security here, what we will do, we will add here VPN. So VPN are according to the requirement. So here we want that branch 1 should able to communicate with branch 2, or we can say site 1 want to communicate with site 2, and which VPN will implement here, that is called site to site VPN. So when we talk about VPN, then we use some protocols. Okay, if you are talking about VPN, then you use protocol, for example IPSec. Okay, if you are using IPSec, definitely you are using VPN. When we are using VPN, then definitely we are using IPSec. Means both will work together, we can say. Okay, here. So now question is, what is VPN here? Okay, so to get the answer of this question, yes, IPsec VPN provides secure IP communication over insecure network. In this scenario, we want that branch 1 or site 1 should be able to communicate with branch 2 or site 2 in a secure way. So a technology, a concept or a feature which will provides a secure connectivity over ISP, and ISP will assume that it is a insecure network. So that VPN, that is called VPN means, or VPN. Okay, again I would repeat here, I will repeat here. When we will use IPsec. When we are using IPsec, definitely we are implementing here VPN. So when we will configure site to site VPN between two branches, so it will provide secure IP communication between branch 1 to branch 1 to branch 2 through insecure network. Okay, IPsec VPN features. Okay, when we will talk about IPsec VPN, then which features are offered to us? Okay, first is here confidentiality, second integrity, third one data origin authentication, and fourth one is anti-replay. Now, question is, when we are using here VPN between two branches, for example, branch 1 and branch 2, when we are implementing VPN through ISP here, now question is that how it will protect, how it will give security to us when we will implement here site to site VPN. So we can talk about the features. First it will give, yes, if we will confidentiality, we can use the PPT. Okay, first it will give confidentiality, second feature integrity, third one data origin authentication, and fourth one is anti-replay. Now we want to know what is confidentiality. Yes, confidentiality means, it means your data will keep as a secret using encryption like dash, triple dash, and AES. Okay, when your data will be moved from branch 1 to branch 2, they it will keep as a secret. Secret means no one will come to know about it. And how we can keep it secret? Yes, we will use here encryption algorithms, and we can use encryption algorithms here: dash data encryption standard, triple data encryption standard, and advanced encryption standards. We can obtain confidentiality using encryption algorithms, and here we can use three. Next one is here. Okay, these algorithms will be used by both peers here. Both peer means here we can say both branch. Okay, for example, if it will use DES, okay, it will encrypt with DS, it will decrypt with DES. Okay, if it will encrypt with 3DS, okay, it will decrypt with 3DES. Okay, and if it will encrypt with AES, same, it will decrypt with AES. So same algorithms we have to use on both sides. Okay, next one is here integrity. It ensure that your data, it ensure that that your data is altered during transmission or not using hash algorithm. What happened? Okay, it is acceptable that no one can see our data. Now what we want to know, that no one should be able to alter our data. Okay, now we know no one can't read, but data should not be altered here. So what happened? This is obtained by integrity. Yes, it ensures that your data will not alter during transmission, and we will obtain integrity using hash algorithms. And here we have two hash algorithms here, MD5 and SHA. Okay, so what will happen when branch 1 will send data? For example, when it will send data, it will put the data into the hash algorithm and it will get a product. Okay, now when this data will offer to another, this hash product will be attached with the data, and this is offered to another. When another device will receive, okay, it will separate both things. First it will separate data and it will separate hash value. Same hash algorithm it will use, it will put the data and it will get a hash product. If hashes are same, it means there is no alteration with data and I will accept it. Okay, if hash doesn't match, it means data has been altered and I will not accept it. So here we have hash algorithm. First one is MD5 and second one is SHA. Okay, next one is here data origin authentication. Yes, what is data origin authentication here? It means both device will authenticate to each other before data exchange using pre-shared key or certificate. So here to understanding data origin authentication, what we have to do here? Yes, okay, when the data exchange will be happen here, before it branch 1 will authenticate to branch 2 and branch 2 will authenticate to branch 1. Okay, it will, when branch 1 will establish session to branch 2, it will say okay, what is your password? Then we will say okay, our password is Shiva. When it branch 2 will want to communicate with branch 1, then it will ask that what is your password, so it will ask also say my password is Shiva. So this is the method of pre-shared key, that you have to define a single key on both side. Apart from it, you can use certificates, and we can obtain certificate from Microsoft CA or iOS CA. So there are two ways. Again, I am saying that before the data will be exchanged between two devices, they will authenticate to each other using pre-shared key, or we can say digital certificates. If they will authenticate to each other, only then data will exchange. If they are de-authenticated, then data will not exchange here. Next in is here anti-replay. Anti-replay means that if your data will arrive late, it will consider as alter and it will be dropped. Anti-replay can be defined in kilobytes or second. Okay, now what happened when both peer will communicate to each other? What we will define? Okay, we will define here lifetime. When branch 1 will communicate to branch 2 or branch 2 will communicate to branch 1, yes, you will communicate for 30 minutes. Okay, okay, what happened? Okay, when they will communicate, yes, they will communicate for 30 minutes, and after 30 minutes, okay, there a tunnel will be created for 30 minutes. Okay, here they will create a tunnel for 30 minutes. After 30 minutes, tunnel will be destroyed. If a peer, for example branch 1 or branch 2, will receive any data from after 30 minutes, then it will be drop here. And we can define the lifetime of this tunnel in two way. Yes, first we can define in seconds, and second we can define in kilobytes. Okay, next one is here when we are talking about IPSec. Okay, IPSec is a terminology which provides us for features confidentiality, integrity, data origin authentication, and anti-replay. But here, when we talk about IPSec terminology, which protocols are used by IPSec, so they are in front of you. First one is IKE, second one is ESP, and third one is AH. IKE. Now we want to know what is IKE. IKE stand for IKE stands for Internet Key Exchange. It provides a framework to exchange the security parameters and policies between two IPsec peers. So for understanding it, what we have to do here, we have to go through a diagram. Yes, suppose we have branch 1 and this is branch 2. They are connected to each other via ISP. Okay, now for confidentiality, here we will define encryption, we will define here hash, we will define here data origin authentication, and we will define here anti replace. Same, we will define here encryption, we will define hash algorithms, we will define data origin authentication, and we will also define anti replay. Okay, we have a variety of algorithms here, for example dash, triple dash, and AES. Hashing for MD5 and SHA. Data origin authentication pre and certificates are there. Here we have lifetime in seconds and or in kilobytes. Okay, same thing we have to define here dash, triple dash, and AES. MD5 and SHA, pre-shared key or cert, or second or kilobytes. Okay, now question is that when a large variety is available about the algorithms, now question is that if this branch is using DES for encryption, it is mandatory when branch 2 will decrypt the data, it will use same dash. If branch 1 is using 3DS to encrypt data, it's mandatory that branch 2 should use 3-2 decrypt. If branch 1 is using AES for encryption, branch 2 should use AES to decrypt. Same, if branch 1 is using MD5 for integrity, it is mandatory branch 2 will use MD5 for verification. If branch 1 is using SHA, then it is mandatory that branch 2 will also use SHA for verification. Same here, if we are using pre-shared key, both sides should be pre-shared key. If we are using certificate here, then both sides should be implemented with certificates here, so that they can communicate or they can understand the message properly. So this information is negotiated between two branches using IKE. So here IKE, Internet Key Exchange, play an important role so that two branches can exchange their attributes. So here we can say IKE, Internet Key Exchange, it provides a framework to exchange security parameters and policies between two IPsec peers. Yes, where we have two IPsec peer, so IPsec peer branch 1 and branch 2, and we want to negotiate the parameters of IPsec features. So these parameters will be negotiated through IKE. So IKE, we can say here, IKE provides a framework between two IPsec peers so that they can exchange their policies, parameters and attributes. So again I am repeating, IKE, this one you can see here, IKE provides a framework to exchange the security parameters and policies between two IPsec peers. Okay, next is here IKE modes. Now, when we will discuss about IKE, then yes, IKE use some modes: main mode, aggressive mode, and quick mode. For understanding, yes, what we have to do, we required a clean diagram here. Yes, same here. This is branch 1 and this is branch 2. Okay, now main mode. In main mode, 6 attributes or messages are divided into 3 steps. First, initiator will send proposal to responder and responder will send own proposal to initiator. Or we can say initiator will send in second step, initiator will send open key to responder and responder will send open key to initiator, and at the end they will authenticate the session. Okay, in roughly we can say here the 6 messages are divided into 3 steps. For example, first one, branch 1 will send its proposal to branch 2, and branch 2 will send open, when it will say send, it is called initiator and this is called responder. So here we can say initiator will send, in first step, initiator will send open proposal to responder and responder will send open proposal to initiator. When proposal will exchange, then second step, initiator will send open key to responder and responder will send open key to initiator. In third step, initiator will authenticate the session, or in same reverse, responder will authenticate the session. First here proposal, second here key, and here third one is session authentication. Again I am repeating here, in main mode 6 attributes or messages are divided into 3 steps. Initiator will send open proposal to responder, responder will send open proposal to initiator. In second, initiator will send open key to responder, responder will send open key to initiator. Third, initiator will authenticate the session, responder will authenticate the session. So this was roughly, but we want to know in the depth. So here what we have to do, we required a new diagram here. Please have patience.